over 1 second going to stop recording for 2 seconds. That's all.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. How are you?
Waalaikumsalam warahmatullahi wabarakatuh.
Everybody okay? Sehat? Alright.
Sehat.
Yes, sir.
So I will today, we will look at the topic chapter number 14. And we will do, I will continue from that. If you, I want you to look at the recording. I hope everybody did look. So I'm going to continue with the function with two independent variables. So that is where I will continue. So you have a function of two independent variables. In general, they call it multivariate function. For us, we just look at the one with two independent variables. And we denote the function, or you write the function y as a function of x1 and x2, where x1 and x2 are the independent variables. And the dependent variable are dependent variable is y.
Sir?
Oh,
We don't see the screen share, sir.
Yeah, I didn't share screen. Forgot to share screen. Thank you. I should share the screen. So now you can see. Can you see now? Okay.
Yes.
All right. So the function, you will normally write y as a function of x1 and x2. X1 and x2 are the independent variables. Y is the dependent variable. So that is the general form. Now, since there are only two independent variables, normally, normal practice, if you look at the book, we write z as a function of x and y. So the x and y now are the independent variables. And z is the dependent variable. So that is how we write down the function. Okay, so we follow the book. Since there are only two independent variables, so we write down z as a function of x and y. So that is notation. Now we want to look at the graph. How does the graph of this function look like? Now, if you remember x and y, x and y, you have the x independent variable horizontal axis, the y is the dependent variable vertical axis. So what you will get is a line. Okay. So in this case, we have z dependent variable, two independent variables. What we will get will be not simply a line. What you get will be object. So object, definite object, like cylinder, cylinder, cube, things like that, or a house, any object, even animals, life object, human. Okay, everybody here are objects. So we call this three-dimensional diagram. three-dimensional graph or three-dimensional. Okay, so everybody, we are three-dimension. So that this is the relevance of this kind of function. Now, how do you draw the graph? Okay, this is how you draw the graph. X and Y are the independent variables. So you put the X and Y now on a flat surface. So this is how you do it. We put Y over here. That's Y, which is, if you look at the one variable case, you have Y going up, right? So now you put it down, you lie it down. So Y will go that way, and then X will go this way. And the separation here will be 90 degrees. Okay, so that is our origin. So if you look at this surface, this flat surface, this is like a floor. Okay, you imagine this is like a floor. And on the floor, you have one horizontal line going to east to west. Okay, Y. And then the other one is going south to north. Okay, that is X. But we do it like this so that we can see the vertical line. Now you go to you bring up a wall, you bring up a wall. So it's going vertical. So that vertical axis, you draw it from the origin there. So we get Z. So now that is how we draw a three-dimensional graph. And the separation between the X and the Y is also 90 degrees. I'm sorry, Z and Y here is 90 degrees. This is also 90 degrees. So total you have 360 degrees. So you imagine now, okay, you imagine now that we are here. So we are here, all right? So we are looking at this side. So this is the room. So this is the room going from north to south to north. And this is the room going from east to west. And that's the wall, okay? So when that's the wall, imagine the wall is going either way. So the X that go beyond the zero is beyond the wall, okay? It's after the wall. So we cannot see that. So you show it by a broken line. Similarly for the Y, you cannot see beyond the wall, so that is broken line. And also the Z, you cannot see beyond the floor, so show it broken. So the broken line or the broken part is basically the negative side, okay? So here you have the positive. So if we put a scale here, so let's say I put it like 5, 10, 15. So this part here is the positive 5, 10. And then for the Y, you also have positive here. And for the X, for the Z, will be 5, 10, positive. And then to the other side of the wall, it's negative. So the X will be negative over the other side. Similarly for the Y, so you got negative 5, I'm sorry, negative 5, negative 10. And the Z down the floor, so that is negative also. All right, okay, so that is the graph. So you imagine that's the floor and the wall. And imagine anything that beyond the wall is negative, and anything beyond down the floor is also negative. So this is the graph. Now the point for this graph, we write it as X, Y, Z. Example, let's say 5, 10, 10. Okay, so we write in the order. So that is the order coordinate, X, Y, Z. So the first value 5 is X, second Y, third Z. So the first two are the independent variables. The last one is dependent variable. Now, next, how do you locate a point? Now, to locate a point, firstly, you consider the x, y first. Okay, so you consider x, y. That means for any x and y, for example, say x is here, and the y is over there. All right, so you consider the point x, y. So that is x, y on the plane, on the floor. Okay, after that, you want to find the corresponding z. So either you go up, okay, you go up the wall or you go down the floor. Okay, you go up or you go down. And then you find the corresponding value of z. So z is the vertical axis. So from that y, let's say somewhere here, all right? So let's say z is somewhere here, z is here. So we have to go up. That, okay, that is. So that is the point x, y, z. So firstly, you get to find the floor, x, y, and then you get the corresponding z. Okay, all right. So let's find the point for that example, 5, 10, 10. So 5, 10, 10, firstly you get the x, y. So that is 5, 10, x is 5, y is 10. So 5, x here, 10 is there for the y. So that will be somewhere here. And then you get the value of the z, which is what? 10. 10 is somewhere there, up. So you go up. Okay, it will be somewhere there. So that is the point, 5, 10, 10. Okay, all right. Okay, now I want you to locate one point. So you locate another point, locate 8, 15, negative 10. Okay, I want you to locate that point and tell me where is the point. Okay, I'll give you 1 minute to do it. Okay, Fuzail, you didn't have your picture here, so I call you. Okay, where is the point?
So, Assalamualaikum.
Yeah, where is the point? Fuzail,
Assalamualaikum.
yeah, where is the point? You get the point? Or you don't? Okay, Muhammad Dafa, where is the point? Where is the location of that point? First, you get the XY, and then match the corresponding Z. Okay, Sawal D. Nisa, where is the point? You got the point?
Not yet, sir. Still counting.
Ah, ya lamanya. Okay, anybody who got it? Nur Izzatul, where is the point?
Sekejap, sir, not yet.
Hah, nak ya juga? Okay, siapa dapat? Siapa yang dah locate the point? Anybody? Syahira, you get the point? Okay, Fatin. Where is the point? Point ini tadi 8, 15, 10. Okay. Fatin, where is the point? You got it? Tak ada? Okay, Zaidatul. One Zaidatul. You get the point?
Not yet.
Ayah. Takkan esok pun nak dapat. Okey, siapa dah dapat? Cakap je.
Sir,
Yes.
is the point somewhere down the floor?
It will be somewhere down the floor. Is that right? Because you have the value of z is negative. Okay. First, you get xy. Xy is 8, 15. So 15 will be somewhere here. Lah. Okay. You can add that 15. So 8 will be somewhere there. 15 is somewhere there. So somehow you got that point 8, 15. Now you want negative 10 for the z. So negative 10 is down the floor. Okay, here. So you take it down like that. So somewhere there. Okay. So now sometimes, the diagram sometimes look like strange, but we just try to be as accurate as we can. Okay. To draw three-dimensional object is not easy unless we have computer to do it. But the thing is, we know how to locate a point. Okay. Thing is, you know how to locate a point. Firstly, you got the xy, that means on the floor, on the plane. And then either you go up, you go down to get the corresponding z. So that will be the point. Okay, any question? Everybody got it? All right, good. So that would be the graph. Now, like I said earlier, this will be object. Okay, it will not be simply a line. So an example of object, you go to the book 14.1, in the textbook 14.1, you will see a good picture, okay, a good picture of example of a function with two independent variables. So go to figure 14.2. You see there the function is z equal to f of xy equal to 4 minus x squared minus y squared. So you see that function. How does the curve look like? How does the function look like for this particular function? How does the graph look like? It's an object. Okay, it's not simply a line. So what kind of object do we call this? You look at part B. Okay, part B is nicer picture. Okay, what kind of object do you call this kind of thing? What shape is it?
3-dimension.
I know, a 3-dimension. That's a 3-dimension. What is the name of the object? Is it a cube? Is it a circle? No, is it a cylinder? Or is it a sphere? Sphere. Kalau circle macam earth, dia become bulat, bola. So what do you call that kind of thing? But that kind of object, what do you call it?
Hemisphere.
Semisphere, right? Semisphere. So more like semisphere, or it look like dome. Dome. So the dome, for the mosque, if you recall, we are, Muslims are pioneer of mathematics. So if you look at the history of us, history of Islam, you can see the design of mosque, very nice dome. The dome they construct is not just simply construct. It's based on some mathematical formula. So the dome, the dome is actually following this kind of function. So you see, it's very, very nice. So I like to view it as it's actually not a semi-sphere. It's not really a sphere. It's more like a dome. So that kind of object. So when when you see this, we remember, okay? We remember our history. We used to be, pioneers of mathematics, and not just mathematics. So many other fields. So for us, mathematics should be easy, all right? Because mathematics is created by the Muslim, but unfortunately for us now, mathematics is something that we don't like. Okay, so that is an example of an object. What I want to do next is we want to take the derivative. So the derivative of this kind of function, you have two independent variables. So the derivative is what you call partial derivative. Now, why you say partial derivative? Because there are two independent variables. Okay, you have two independent variables. When you do the derivative, we do the derivative with respect to, okay, we do the derivative or we differentiate. Okay, I think we use differentiate, sounds good. We differentiate z with respect to only one variable at a time. With respect to one variable at a time. So that's why you call it a partial derivative at a time. Now there are two, okay, there are two independent variables. But when you differentiate z, we differentiate with respect to one independent variable at a time. Okay, so that's why you call it partial. Okay, you differentiate one variable at a time. Now, what happened to the other variable? The other variable or variables, if there are more than two, all right, we kept constant, kept as constant. Now, the other variables, they are not constant. You just kept them as constant. Kept them means treat them as constant. Imagine that they are constant. So you can use the word treat them as constant, or you can use imagine they are constant. So when they're constant, you apply the derivative rule of constant. So that's why you call it partial derivative. We differentiate z with respect to only one variable at a time. The other variable we keep as constant. So that's why you call it partial. Okay. So when you have independent variable x and y, okay, are you done? If you want to write, are you finished? You finished this one? Finish.
Not yet, sir.
Okay. Faster. Okay, when you finish, let me know.
Now, okay, sir.
Okay, so that's the basic idea. All right. So now let's go into specific x and y. So if you differentiate, okay, if I differentiate z with respect to, so now I use short form WRT. WRT now meaning with respect to x. Okay, one independent variable. Now what happened to y? Y is the other variable. So y is treated as constant. So y is kept or treated as a constant. Okay. Now, if I do the derivative with respect to the other variable, that means y, I'm sorry. If I differentiate z with respect to the other variable, which is y, because there are two independent variables, all right, you differentiate with respect to one at a time. So there are two. So differentiate one, and then you differentiate with respect to the other. With respect to y, what happened to the other variable? Now the other variable is x. So x is kept constant. Okay, so that's why you call it partial. Now the way you write the notation will be something like this. So notation, when you take derivative with respect to x, we call it z. So it's a subscript, it's not, the x shouldn't be like z multiplied by x. It should be like z subscript x. Or we write it as fx. Okay. Oh, there are a few other notation, but I think we just use these two. So if you look at the book, they have a few notation, or you can write df dx. or we can write dz dx. But we prefer this one, you know, it's simpler to write. And then for the derivative with respect to the y, we write zy equal to fy equal to df dy equal to dz dy. Okay, I think it's good that I wrote the d. Now, if you look here, the d here is not the d that we used to have. The d we used to have is just dy dx, straight d. Okay, the d here is delta d, the slanting d. So if you see this kind of notation, you know, the slanting d, all right, this one, that is what? That is the partial. That is indicating partial derivative. So partial. So it's good that I wrote the df dx. You know, I didn't intend to write that thing, but that will differentiate. Okay, differentiate the derivative dy dx if there is one independent variable to the case where you have more than two or more independent variable. We denote by that delta. Okay, so that indicate the partial. Or sometimes we just commonly write zx, fx, zy, fy, and we know that the function is, you know, is consisting of two or more independent variables. So this is the idea of partial derivative. Okay, any question? Okay, good. Now next, the rules of derivatives. Everything applied. So we don't need any new rules. The constant rule, the product rule, the quotient rule, the power rule, everything will be applied. Okay, the same rules. So rule applied, we know already. The only thing that we don't know, okay, or we are yet to learn, is that you differentiate with respect to one variable, you keep the other variable constant. So that is what we are going to do now. So let's look at an example. First, there are two types of things. Okay, I'm asking you now again. Are you done with the notation? Yes. Okay.
Answer.
Okay. So now there are two types. Okay, two types. One is the x and y, which are the independent variables. One, they are additive. They are added or subtractive. Okay, subtract. And number two, they are multiplicative. Okay, multiplicative, or they are divisive. Divisive or divisive. Or they are divided. Divide. Jelas nanti itu. Okay, multiplicative, additive, senang. Subtractive, subtract. Divide, division, divisive. Maybe divisive. So divide. So these two. The first one is very simple. The second one, sometimes, you know, to get the idea is not that straightforward. All right. So sometimes, you know, for this part, at the beginning, we tend to commit error. So I will do a few examples to see the difference. Now, let's look at example for the first one. Say you have z equal to f of xy equal to 5x to the power of 3 minus 31 y to the power of negative half plus 30 plus dari 3 lah plus 70. So here you will see the x and y are additive lah or subtractive. Okay, you have a subtraction here. And remember the rule. When you take derivative with respect to x, y is constant. When you take derivative of y, x is a constant. So let's do that. Now you want to take derivative with respect to x, we call it zx or fx equal to, all right. So the x is the variable. Okay, so we start with the easy one. So this x, this time is the variable. x cubed is the variable. So what is the derivative of this term?
(15x squared, sir).
15x squared. Okay. Now here you got 70 constant. What is the derivative of 70? 0. Okay. Now thing is, now you have 31y to the power of negative half. Okay. Now what the rule say? Or what was the principle about? The principle say y is kept constant, or you treat y a constant. So this y now is a constant. You think of it as a constant when you do the derivative with respect to x. It is not a constant, okay? But when you take derivative with respect to x, you treat that as a constant. So now I got 31 is constant, y to the power of negative half is a constant. So what is the derivative of that term?
Is it the same, sir?
Same what?
31y to the power of half minus half.
Okay, so one idea, negative 31 y to the power of negative half. Okay, that's a good idea. Okay, anybody have another answer? Anybody? That y is a constant, okay?
Is it 0?
So another one is 0, okay? Now, which one is true? Which one is right? Is it 31y to the power of negative half, or is it 0? Because y to the power of negative half is a constant. So you imagine that z constant, say a number. Okay, imagine a number 4. For whatever number you want, 1, 3, imagine that's 4. Okay, so you have 31 and 4, which is a constant. What is the derivative of that term?
0, sir.
0 lah. Okay, so it is not negative 31y to the power of negative half. It is what? It is minus 0. Okay, so minus 0, as good as you don't have to write anything. But in order for us to establish the rule, okay, for the beginning, I just write here minus 0, okay, to indicate that thing. But eventually, you don't have to do anything. That will be it. Okay, any question? Okay, good. Now, I take the derivative with respect to y. So in this case here, the function, okay, not the function, when you take derivative with respect to y, what is the variable that you keep as constant?
X.
X. So now x is the constant. So you think of the x as a number 3 or 4, whatever, but it's a constant. So you have 5 multiplied by x, and that is a constant, say 4. So what is the derivative of that term?
0.
0. Okay, 0. Now the variable is y. Okay, so this is the variable y, so there is no problem with that one. So you take the derivative, negative 31 multiplied by negative half. Okay, and then you got y to the power of reduced by 1, so negative 3/2. 70 derivative is 0. So that is our derivative. So that is the partial derivative. Okay, you treat the other variable as a constant. So let's do another example. So I want you to go to 14.2. Okay, look at 14.2. I want you to try a question number 2. Okay, question number 2. So 14.2, question number 2. Okay, but so you got here more than one terms in x and y. So don't worry about that. They are all additive or subtractive. So that's the rule. You differentiate with respect to x, y is a constant. You differentiate with respect to y, x is constant. Okay, exercise 14.2. Okay, I give you some problem for practice. 1 to 12. Okay, we do number 2 now. So you do 1 to 12 at home. And then okay, 14.1. Again, here you do from 1 up to 12. So if you look at 14.1, they ask you to find the domain. They want to evaluate the value of the function. Okay, so don't worry about those. What you do for 14.1, you just do the partial derivative. Okay, do fx, fy. Similarly for this one, you do fx, you do fy. 14.2 to maybe more specific. You know, they want you to find the partial derivative. But 14.1, the question is not to find the partial derivative. The question is to find something else. So don't do that. You find simply the derivative. Okay? All right. Okay, now go back to 14.2, question number 2. Okay, what is the derivative? Anybody? Number 2? Okay, what is derivative? Just tell me. Zx, or you can write fx. Okay, what is it? The first term. What is the term?
5x4.
5x to the power of 4. Okay. Now, second term, 6x. What is the derivative? Huh?
Minus 6.
Minus 6. Okay. Third term is y to the power of 4.
Minus
What?
6.
Betul, minus 6. Now, the next term, 4y to the power of 4. So, what is the derivative of that term?
0.
0. Or the last term? Y squared?
0.
0. Okay. So, that's it. Okay.
0.
0 juga. So, you don't have to write lah kalau 0, 0 tu. Okay. Now, you take derivative with respect to y. Zy of fy. Now, y is the variable, x is the constant. So, first term, x to the power of 5. What is the derivative?
16y to the power of 3.
No. Now, okay, you take derivative with respect to y. X is a constant. Okay, x now constant. So, what is the derivative of x to the power of 5? 0. Okay,
0.
0. You don't have to write 0 aja. And then the second term, negative 6x.
0 also.
0 juga. Okay. Then the third term for y to the power of 4, that one is a variable, so that will be 16 y to the power of 3. And then the last term minus 2y. Okay, is that clear? Or do you want another example? The additive or subtractive. Clear? Everybody clear? So when you do the derivative with respect to x, y constant. When you do derivative with respect to y, x constant. And you apply the constant rule. Okay. All right. So you go home, you know, do the questions that I give you here, and you'll get more familiar. Okay. All right. Now we look at the multiplicative term or divisive term. So example number 2 is multiplicative. So example, let's say I got z equal to f of xy equal to 10x to the power of 5 over 3, y to the power of 6. Okay. So now you remember they are multiplicative. Okay, they are multiplicative. So you treat the variable as a constant. just like the number 10 there. Okay, all right. So I want you to try this. Do the partial derivative with respect to x, and then do the partial derivative with respect to y. Dia tentang internet saya ni kurang stable sikit. Okay, you got it? Okay, we do the partial with respect to x dulu. Okay, don't worry about the partial with respect to y. We do it one by one. So we do this one first. Okay, and then we do the other. All right, anybody who got it? You got it, doesn't matter whether that's wrong or that's correct. All right, you share your answer and then we will evaluate. Okay, what is the derivative here? Zx. Anybody who has finished, you can share yours. After that, okay.
5/3 multiply 10
Okay, tunggu ya.
x
5/3. Okay, 5/3 multiplied by
10
10,
x the power of 2/3
2/3,
y power of 6.
y to the power of 6. Okay, I put bracket. All right. Anybody who get a different answer than this one? Anybody who got different? Okay, give your answer to me so that we can evaluate. Anybody?
Same, sir.
Same. Everybody got same?
Yes.
Okay. So everybody got the same? That's good. Okay, so when you do the derivative with respect to x, it's multiplicative. So the y to the power of 6 is the constant, is another constant. Okay, so you already have a constant, which is 10. That is a constant. Okay, I use another color. That 10 is a constant. Now you got y to the power of 6, which is also a constant. So it's convenient that you put the constants together. So what you can do is this. You write, okay, you write z equal to 10 y to the power of 6. So that is constant. Okay, y to the power of 6 is now constant. You imagine that number is say 5. Okay, so you have 10 times 5 is constant, or 5 to the power of 6. So the constants, put them together. So don't worry about them. Okay, the rule says what? The rule says the constant will just follow the derivative. So the variable is only what? X 5/3. So this one is the one that you take the derivative of. All right. So when you take the derivative, what do we get? So we get the term Zx equal to what? Equal to 10 y to the power of 6. Okay. And then you got 5/3 multiplied by x negative, not negative, 5/3 minus 1, so you got 2/3. Okay, so of course you can simplify, so you got 50/3. So that will be equal to 50/3 y to the power of 6 x to the power of 2/3. So one way to not being confused, okay, you put the constant variable on the left, just like the other constants that you may have, and then differentiate simply the variable that is a variable. Okay, all right. So now get x, y. So when you do derivative with respect to y, okay, so the term 10x to the power of 5/3, okay, that is a constant. So you just differentiate the x to the power 6 now. Okay, now get z, y. So you put the things together, all right? You put the constants now and x to the power of 5/3. Okay, they are together. And then you've got y to the power of 6. So these are the constants. So don't touch them. Okay, they will just follow the derivative. So what is the derivative? Zy? Zy equals what? Anybody?
6y to the power of 5.
Okay, 6y to the power of 5.
Times 10x to the power of 5 over
You
3.
multiply by the constant, everything there. Okay, so 10x 5/3. Okay, or you maintain in that order. You put the constants at the beginning. Okay, and then you multiply by derivative of the y to the power of 6. You get that. Okay, so either way that's correct. Okay, all right. So when you take derivative with respect to x, y constant. When you take derivative with respect to y, x constant. And the rules apply. So I would like you to try another question, okay? Just for your practice. Do question number, go to 14.1. 14.1, do question number, question number tak ada. 14.2. Itu tak, mungkin ada. 14.2, go back to 14.2. You do the example 11. Okay, do example 11. Now, the example 11 is interesting because they want to find the second partial. Okay, but we don't have to worry about the second partial because we haven't learned second partial. So you find the partial derivative. That is the first partial. So you got zx, and then you find zy or fx or fy. Okay, everybody got it? So that example 11, nih, function nih. Z equal to x cube y minus, benda-benda tu. Okay, minus, I write it down in case you don't have your book. 3x y squared plus 4. Okay, do it now. By now, you know, you should do this very fast. Okay, first find the zx. Okay, dapat dah. Okay, Nur Farah Wahida. Okay, what is fx?
Yes, sir, not yet.
Huh? Not yet. Aduh, ya, berapa lama ni? Cepat. Okay, siapa yang dah dapat cakap?
3x squared y.
Okay, 3x squared. Okay, now the y is a constant. Okay, but the y is multiplicative. So you just bring it together. Okay, by now you don't have to put the y, you know, on the left. By now, I think if you know already the principle, so you just keep the y where it is. Okay, the next.
3y squared.
Okay, 3y squared. Okay, 4 is a constant, clear constant, so that will be 0. Okay, all right. No, Farah, you got it?
Yes.
Okay. Okay, good. So make sure, or if we are not sure yet, you write what I did earlier. You bring the constant, which is y, to the left side. That you can see easier, as a constant. So we do this. So that's okay. We write another step in order for you to find the fx. So we write z equal to y x cubed minus y squared 3x plus 4. So you know that that's a constant. Okay, the constant, think of a number 5 or 10. So that constant will just follow the derivative. Okay, so what is the derivative? Zx or fx equal to what? Equal to y. Don't worry about the y. It's a constant. Multiply by what? 3x squared. Okay, minus, you got that y squared. So don't worry about the y squared. It's a constant. Multiply by what? Multiply by 3. And then 4 is a constant. And you rearrange again. And then dapatlah macam ni. Okay. Okay, next. Fy. So if you are not sure yet, all right, you will rewrite like what I do here. So when you want to find Fy, you bring x to the beginning. So x to the beginning tak ada apa lah, because that is what we originally have. So macam ni tak ada benda lah, sebab x cube kat situ. 3x pun dah on the left. So tak ada hal, senang cerita. Okay, sebab y dengan y squared, y is the variable. Okay, so what is the derivative? Fy. Tu mak siapa pula mengaji tu? Okay, cepat. Apa dapat?
X to the power of 3.
So x to the power of 3. Okay, y is the variable. So variable differentiate y is just 1. Okay, so you don't have to write anything. Minus?
Minus 6xy.
Minus, you got 3x. Okay, we do the step. Okay, you 3x and then you got 2y. Okay, the derivative of the y squared, 2y. So basically 6xy. So you can write x cubed minus 6xy. Okay, all right, good. So now I give you a function that require us to apply product rule. So product rule, you still apply the product rule, all right? And then you do for the partial derivative. So let's say I got z equal to f of xy equal to 2x squared minus y to the power of 5 multiplied by multiplied by 4x to the power of half plus 5y negative 3. Okay, everything to the power of 7. So now what you do, okay, you apply the power rule. So first, I want to find Zx, which is Fx. So you recall the power rule. Okay, what is the power rule? Power rule, y prime equal to what? U prime v plus v prime u. So apply to that thing. Okay, so now you let u be the first part or the first term, v equal to the second term, and then the u prime v prime is the derivative with respect to the variable that you are differentiating with respect to. Okay, so if you want to find zx, that means this v prime u prime is the derivative with respect to x. Okay, all right. Okay, so do it now, and then we come to the other one. Okay, so let's go through this. So you let u be equal to the first part. So u is equal to 2x squared minus y to the power of 5. Okay. Now, what is u prime? So u prime now is du dx. Okay, because we are taking the derivative with respect to x. So y is a constant. So what is the derivative of this term? Anybody?
5.
You got 5 multiplied by everything in the bracket. Okay, that's the rule. Reduce the power by 4, by 1, not by 4, by 1. So it becomes 4. Okay, now differentiate the terms in the bracket. What do you get?
4x.
4x, yeah. Okay, because y is a constant. Okay, okay, right, good. Now you let v be the second term. You got 4x to the power of half plus 5 to the power of -3. Everything power 7. So you want to find v prime. Now that v prime is dv dx. Y is a constant. Okay, y is constant. No, I'm sorry. Yeah, y constant. Okay, so what is the derivative? So you got the 7 multiplied by everything in the bracket. All right, plus 5y, -3, reduce the power by 1, 6. Okay, now you will differentiate terms in the bracket. What do we get?
2.
2,
2x
2x to the power of
minus half.
-half. Okay, so that's it. So you apply to the formula. Okay, so the formula zx equal to fx. The formula u prime v plus v prime u. That's the product rule. Okay, so you finish up at home. We just want to break up the term. Okay, finish it up. Now let's move on. We want to find the other partial, which is zy or fy. All right. So zy equal to fy equal to. Again here, you let u be the first term, v the second term, but all right, but the u prime, okay, the u prime now is not du dx. The u prime is what? Since you are taking derivative with respect to y, the u prime is, okay, so that we know what we are doing. So you just write du what? Du dx. No, I'm sorry, not du dx, du dy. Because we're taking derivative with respect to y. Okay, so du dy. So our y prime is du dy. Y is the dependent variable. X now is the dependent variable. Okay, so again, you let u be equal to the first term. Okay, I want you to try first. 2x squared minus y to the power of 5. So now our y u prime, okay, remember our y prime is du dy. Okay, and similarly the v prime now is what? dv dy. Okay, finish it up. So I will do here, you do on your own, okay, for a few minutes, and then we come back. And then v is equal to Okay, got it? Okay, what is u prime? So now u prime, okay, remember the prime is the derivative of the u with respect to y. Okay, what do you get? U prime here. First part, no problem, okay? Everything is the same. You reduce, you bring down the power, reduce the power by 1. Okay, so you got power 4. Now, how do you differentiate the terms in the bracket? Okay, that will be the difference. Okay, what is the derivative of the term in the bracket?
-1.
-1. All right, because you are taking now du dy. Okay, x is the constant. So similarly for the v prime, okay, everything first part no problem because you keep the things in the bracket and then you reduce the power by 1 and then you multiply by the derivative of the terms in the bracket. So what is it? So now it's dv dy. Okay, y is the variable. So what do you get? Anybody?
-15.
-15. Y to the power of not 2. You got -3, take away 1, -3 minus 1. It's not -2.
-4.
-4. -2 means you plus 1. So I got v prime, I got u prime. Okay, now put into the formula. So the formula, you recall the formula. The basic formula, u prime v plus v prime u. So that is the basic formula. All right? Okay. But don't confuse, this y prime is the one that we guide, use our guideline. So that was y as a function of x. So that y prime, is not y prime here. Okay, this is just to what? To get us the formula. Okay, whatever the function is, the formula is this. So you apply the formula. Okay, so don't confuse that y prime with the fy. Okay, so that y prime is just to get the formula. Okay, so for us to guide, to get the formula in case, okay, in case we forgot, because the formula for that thing, every rule is applicable. Okay, all right. Now I'll give you one more. Okay, this one you apply the quotient rule. Okay, so here I want you to use the quotient rule. So go to 14.2. All right, 14.2, you do question number 38. 38, you have 2y squared divided by something. That is the function. Of course, the question asks you to find the second derivative. Don't worry about that. You need only to use that question to find zx, zy, or fx, fy. Okay, so do that question. Now, for the quotient rule, the formula is, you have to remember the formula dia apa? The basic formula y prime equal to what? U prime v minus v prime u. Everything divided by v squared. I think. So this is the formula. So you apply this thing here to fx and fy. Okay. All right. I do it now. I give you 3 minutes. We do just fx first. Okay. Do fx first. And then we proceed to fy after we discuss the first one. Okay, so you let u be the numerator. So it's 2y squared. Okay, so now you need u prime. So what you want to find now? You want to find fx. Okay, fx was fx. So that u prime, okay, that u prime is derivative of u with respect to x, not with respect to y. So what is u prime here? Hello, hello, hello. Anybody home? What is the derivative of 2y squared?
Oh.
0.
0, because y is a constant. All right. And then you look at v. What is v? V is 3xy plus 4. Okay. So you want to find v prime. I'm sorry, v prime. V prime here is what? dv dx, because we're taking derivative with respect to x. So what is v prime? Y now is a constant. So what do I get? 3, here is 4. Okay, by now you should be doing this very fast. This is already the third exercise. Okay, apa derivative with respect to y here?
3y.
3y. 3y. Okay, because the variable is x. Okay, you got 1, so 3y. So now you got this, you have put into the formula. All right, so the formula for zx equal to fx equal to u prime v. U prime is 0 multiplied by v, 3xy plus 4. Okay, take away v prime, 3y multiplied by u, 2y squared. Okay, everything divided by v squared, which is 3xy plus 4, everything squared. Now the first term here is 0. So what you left will be the second term. Okay. Okay, good. Okay, now you do the second partial derivative. Not the second partial. You do the other partial, zy, which is fy. Again here, that's the rule. Okay, u prime v minus v prime u. So now, when you do the u equal to 2y squared, the u prime, okay, now u prime, okay, you do it. U prime is dy, du, dy. Okay, it's not du dx because we are doing the partial derivative with respect to y. Okay, so I want you to take your time, not your time lah, to do it quickly. Get u prime, v prime. Oh. Okay, so I will just do it here. All right, I want you to do it separately lah, because now I don't have to write another space. So I will do it here. So what is u prime? I do it here. What is u prime? Now u prime is du dy. Okay, it's no more dy dx. So you remember what we're doing is fx. Oh no, I'm sorry, fy or zy. So what is u prime, which is du dy? What is it?
4y.
4y. Okay, very easy. Now, what is v prime? V prime now is dv dy. So what is it? The y now is the variable. Okay, x is a constant. So what is v prime?
3x.
3x. Good. Okay. So you got the u prime, you got the v prime. Apply again the formula to the zy. So you got it. Okay. So you have finished it up. Okay. Finish up at home. Okay. Finish up afterwards. Okay. Now I give you. This is the power. This is the quotient rule. Okay. That's quotient rule. We already look at the product rule. So just remember all the rules apply. Okay, there will be no new rules. The only difference is here we are taking it with respect to x and y. Okay, all right. So next, okay, we go on to 14.2. Actually, we are in 14.2 already, or 14.1. They are together. So we are going to look at the second partial derivative. So second partial. Sometimes we just call it partials. Okay, or the second partial derivatives. This is just like the second derivative. Okay, second partial derivatives, or we just call it short form second partials, is the derivative of the derivative. Okay, it's just like the second derivative. So if I go from the function z equal to function of fxy, I take the derivative with respect to x. I got zx equal to fx. I got zy equal to fy. Now, this is what you call the first partial, or simply the partial derivative, or you call it first partial. The second partial is the second derivative, is the derivative of the first partial. So here we differentiate, okay, differentiate the first partial. So in other words, we differentiate zx, which is equal to fx, and also we differentiate fy equal to fy. Okay. Now fx and fy, they are function of x and y, just like the father, which is z, is a function of x and y. So therefore, the derivative or the partial derivatives are functions of x and y. All right. So each of these, we can differentiate with respect to x. Okay, with respect to x, and also with respect to what? With respect to y. So each of these. So I think I make myself more clear. Each of these, that means zx, okay, zx of fx, I can take derivative with respect to x. I can also take derivative with respect to y. Similarly, fy or zy, I take derivative with respect to x. I also take derivative with respect to y. So second partial, how many do we get? We get 4. 1, 2, 3, 4. Okay. Derivative of fx with respect to x, derivative of fx with respect to y. That's 2. Derivative of fy with respect to x, derivative of fy with respect to y. That's another 2. So that is 4. So the derivative of the second partial, all right? I put here the second partial. I take derivative of zx with respect to x. So I write down the notation. Zxx equal to fxx. So that is the derivative of zx with respect to x, or derivative of fx with respect to x. Now, I take also derivative of zx with respect to what? With respect to y. So that is equal to fxy. Okay? So you can think of it as the first one. Betul ni. Okay. Now zy also same thing. I can take derivative of zy or fy with respect to y, and then I take derivative with respect to x. So for this thing here, you got zyy equal to fyy, and I take derivative of zy with respect to x. I got zyx equal to fyx. So altogether 1, 2, 3, 4. So 1, 2, 3, 4. So there will be 4 second partials. First partial you have 2, second partial you have 4. Okay. So that is the second partial derivative. It's the derivative of the partial derivative, just like the second derivative. Okay. Any question? All right. So now we go back to the examples that we have done, and we apply this principle. Okay. Differentiate again. Okay. Differentiate again with respect to any particular variable. So we go back to the first example that we had earlier. Mana dia tadi? Okay, example mula-mula tadi. Ni dia. Our first example. 4 minus x squared minus y squared. The derivative, first derivative is, we didn't do that. Kita tak buat ya. Kita buat sini. Tak apa. Ini senang kita. Okay, we go back to that example. Okay, 14 minus x squared minus y squared. Okay, by now, we can do this quickly. Give me or find for me the zx, the fx. Okay, what is zx or fx? Hello, hello. Anybody still awake?
2x.
2x. What is zy?
2y.
Not 2y. Oh, I'm sorry, not 2x, not 2y. What is it?
Negative 2x.
Negative 2x, negative 2y. Okay, don't forget the sign, okay? The sign. Don't throw away the sign. Okay? All right. So these are the partial derivatives. So I will write down. All right, I will write down. So you got zx equal to fx equal to negative 2x. And then I got zy equal to fy equal to negative 2y. So here is a function of x and y. All right, fx, y is a function of xy. So therefore, okay, I can find fxx or zxx. Differentiate this thing here with respect to x. What do I get? Don't worry about the original function, okay? Just look at this thing because you want to differentiate this function with respect to x. So what do I get?
Negative 2.
Negative 2. Okay? Now, I can also take the derivative of the fx with respect to y, zxy, or fxy. So what do I get?
0.
0, because x is a constant. Okay? So similarly here, I got fy equal to negative 2. I take the derivative zyy. We do it with respect to the same variable first, senang sikit. Fyy. So what do I get? Negative 2. Okay? I differentiate negative 2y. Okay? I differentiate this thing here. I got that's it. Now, I differentiate with respect to x. Fyx. So what is it equal to?
0.
0. Okay? Because y is a constant. Okay? So the second partial is the derivative of the first derivative. Just like what we were doing earlier. Okay? The difference only what? difference only now you have two independent variables. So our second partial will be 4 total. Okay, will be 4. You got fxx, fxy, fyy, fyx, because you have two first partial. All right. Now, before we go, let's look at the second example. Okay, the second example that we had earlier was this one. Okay, so this example number 11. Okay, I think we start here aja lah, senang kita. So we have, all right, I have fx will be this one already, fy will be here. Okay, everything is already being rearranged nicely. So what I want you to do, find fxx first, okay? Find fxx, fxy. Okay, do it now. Okay, you've got fxx. I think I'm going to write it here je lah, senang kita. Or maybe I don't have enough space. So I'll move forward. Okay, I'll move to the end. Okay, now for the second example. What is fx? Anybody who get it? Just share. Gimana? Okay, what is the derivative of fx? The first term, what do you get?
3x squared y.
3x squared y. Okay, derivative of that thing. You have to differentiate the term. Oh, I'm sorry. We are talking about the second derivative. Should be zxx, fxx. Okay, so derivative of the derivative. So the derivative, what you said is 3x squared y. That's the first term. So differentiate that with respect to x. What do we get?
6xy.
6xy. Good. Okay. So 6x, y. Y is the constant. And then 3y squared. What do we get? The other term, negative 3y squared. Differentiate with respect to x. 0. Okay. Tak payah write lah. Okay. Second, z, x, y. fxy. Derivative of the fx with respect to y. So first term, what do we get?
3x squared.
3x squared. Okay, 3x squared. Now the second term, is it, what do we get?
Minus 6y.
Minus 6y, because the second term now is the variable 6y. Okay, so that is zxx, zxy. Now look at the zy or fy. We take the derivative of the zy with respect to y. So we got fyy or zyy. So now the variable is y. Differentiate fy, okay, with respect to y. So what do we get? First term, x cubed. So what it become? The derivative of x cubed?
0.
0. So you got negative 6xy. So what will be our answer here?
Negative 6x.
Negative 6x. Okay, the derivative of y is just 1. And then zyx or fyx. Okay, so what do we get? Derivative with respect to x. Okay, give me the answer.
3x squared.
3x squared minus
6y.
6y. Good. So if you look at the examples that we do earlier, okay, the rule to see whether we did the derivative correctly or not, we should have fxy must equal fyx. It's not that you use this rule just not to get the solution. Okay, you get the solution and see whether are they equal or not. If they are equal, that means we got it right. So if you look at fyx, I'm sorry, fxy, fyx, they are the same. So equal. So that means we are right. Okay. First example, fxy, fyx, both are 0. So we are right. Okay. So one way to check whether our second derivative everything correct, fxy must equal to fyx. Okay. Okay. So the questions that I give you earlier, some of them. Okay. You don't have to do all. You also do the second question. Okay, I give you here a lot of questions because I want you to practice until benda tu jadi kacang. Okay, kacang senang je nak buat, tak payah nak fikir banyak lah. Okay, you know when is the other variable is a constant, you know what the other variable is a variable. Okay, so you practice a lot of this, you will be more or less expert lah. So that is what we want to establish before next week, okay? Because next week we are going to look at maximum, minimum, some application. So in order to do that, we must be able to do the basic principle. So I think we did enough. So I give you some questions. You practice those questions until you feel comfortable, okay? So the more questions you do, the better you are, all right? You don't have to do all, okay? But if you have to do all, then no problem. That's good. Okay, so practice until you are until this thing become very easy to you. Okay, all right, good. Any question? Any comment? Okay, tak ada, tak apa. So now we are done for today, and I will see you again next week. Have a nice weekend. Okay, take care, because now the COVID-19 is increasing again. Especially new state, you know, in Kelantan kes dah naik, Sarawak pun dah naik, you know, Selangor tu memang dah naik, Johor pun dah tinggi, you know, so there are new states coming up. So take care of yourself, you know. If you are in Kelantan, you are in Sarawak, take care lah. Of course, everybody has to take care, right? But you must be aware, you know, some states it's more the increase. Okay, the dy dx is increasing faster, you know. So here we are talking about the derivative, you know, the slope is increasing. So Kelantan, you know, the slope is increasing, and Sarawak, Selangor, the slope is not increasing. Selangor, the slope is stable. Yeah.
Yeah, I think that's the application for measuring the not like everything like for the pandemic you use a derivative if I'm not mistaken.
Yeah, that's
not only
good.
the logarithmic, not only the
that's true. You know, you look at the daily cases, you look at the change, all right? So basically that's the slope. So you look at the change, you know, if you look at Kelantan, the change is increasing. You look at Selangor, the change is not that much because Selangor is already high. Okay, so you can compare the slope. So we just use the linear function, okay, delta y over delta x, y2, x2 minus y2 minus y1 over x2 minus x1. x2 and x1 is the day, okay, day 2 minus day 1. So no problem, just one day. Yeah, the case is the y2 minus y1. So you look at the, if you have time, yeah, that's a good thing to apply. You look at the data, you know, you look at, yeah, maybe you can look at Selangor. Selangor is the one that is always high, okay? And you look at the one that is increasing recently, Kelantan. So you do only 2 states, or maybe if you want, you do Sarawak, okay? So you can see, I think, you know, I haven't done it, but you can do it. The Selangor, the change or the slope is almost stable, but Kelantan is increasing. So you can look at the slope. Okay, yeah, that's good. Okay. So if you follow the pandemic, some of the things is relevant to what we are learning. Okay, so because that's how they do analysis anyhow. Okay, they look at the change, they look at the level. That's all they look at. Okay, of course there are some complicated things, but we don't look at those. That's beyond our level lah. Okay, okay, good. So I'll see you again. Have a nice berbuka puasa. Have a nice taraweh, and I'll see you again. Okay, do the questions. Okay, do the questions. Don't just sleep. Okay, do the questions. Okay, all right. I'll see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Thank you, sir.
Thank you,
Thank
sir.
you,
And have a
sir.
nice weekend, too, sir.
Salam, sir.
Yeah, have a nice weekend. Inshallah, I will have a nice weekend.
Thank you, sir.
I have a nice cooking weekend.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Thanks. Thank you.
Thank you, sir.
Okay, thanks.